Have you ever wondered what would happen if lightning chose you instead of the ground? For a brief instant, a single bolt can release more energy than most homes use in an entire month. Yet that incredible flash lasts for only a tiny fraction of a second. It appears and disappears so quickly that our eyes barely have time to understand what they have seen. So what is actually happening inside that blinding streak of light? It all begins high inside a storm cloud. Tiny ice crystals and droplets constantly collide as powerful winds toss them around. These endless collisions separate electric charges. Positive charges gather in one part of the cloud, while negative charges build up in another. The imbalance grows larger and larger, turning the cloud into a giant natural battery. But electricity cannot remain trapped forever. As the difference in charge becomes extreme, the surrounding air begins to lose its ability to act as an insulator. Normally, air blocks electricity. During a storm, however, the electric field becomes so intense that the air itself starts to break apart. That is the strange part. The air transforms into a path filled with charged particles called plasma. For a moment, the sky creates a glowing highway that electricity can race through. The first part of the bolt is almost invisible. It creeps toward the ground in tiny steps, searching for the easiest route. Scientists call this a stepped leader. It moves so quickly that we never notice it with our eyes. Then something unexpected happens. Objects on the ground, trees, buildings, power lines, and sometimes even people can send invisible streams of positive charge upward. The instant one of those rising streams connects with the descending leader, the circuit is complete. What we recognize as lightning is actually the powerful return stroke rushing upward through that channel at nearly 1/3 the speed of light. For less than 1,000th of a second, the air inside that narrow path reaches temperatures of around 30,000 degrees Celsius. That is roughly 5 times hotter than the surface of the sun. The air cannot expand gently. It explodes outward almost instantly, creating a powerful shock wave. As that wave travels through the atmosphere, it becomes the deep rumble we know as thunder. That delay between the flash and the sound is more useful than it seems. Light reaches your eyes almost immediately, while sound moves much more slowly through the air. Counting the seconds between the flash and the thunder gives a rough estimate of how far away the strike occurred. But lightning does not always behave the way we imagine. Some bolts never reach the ground at all. They jump between clouds. Others stretch across the sky for hundreds of kilometers, connecting distant parts of the same storm. Scientists have even discovered gigantic electrical discharges that shoot upward from thunderclouds toward the edge of space, briefly lighting the upper atmosphere with mysterious flashes of red and blue. Despite centuries of study, lightning still holds unanswered questions. Researchers continue investigating exactly how storms produce the first spark that begins the entire process. The answer may help us better predict dangerous weather and protect lives around the world. The next time the sky suddenly flashes, remember that you are watching billions of tiny particles organize themselves into one of nature's fastest and hottest events. For a heartbeat, the atmosphere rewires itself, turning ordinary air into a glowing river of plasma before quietly becoming invisible once again. And by the time the thunder finally reaches your ears, the lightning itself has already become part of history.